In the vast expanse of our solar system, discoveries await those who look up. In 2001, a team of astronomers led by David Jewett and Scott S. Shepard at the University of Hawaii set their sights on Jupiter. They were rewarded with a remarkable find, a previously unknown moon, a tiny point of light dancing around the gas giant. This new member of Jupiter's already large family of satellites would be later designated as Hermippe. The discovery of Hermippe, like many other celestial objects, was made possible by advancements in telescope technology. Larger mirrors and more sensitive detectors allowed astronomers to peer deeper into space and resolve fainter objects. The discovery underscored the ever-evolving nature of our understanding of the solar system. Finding a new moon is always exciting, but Hermippe's discovery was particularly intriguing. Its orbital characteristics hinted at a shared history with other Jovian moons, suggesting a larger story waiting to be uncovered. In the tradition of astronomical discoveries, the newly found moon needed a name. Drawing upon Greek mythology, astronomers chose Hermippe, a lover of Zeus, the Greek equivalent of the Roman god Jupiter. The name is fitting, as Hermippe, the moon, is eternally bound to Jupiter, the planet, in a celestial dance that has lasted for billions of years. The name Hermippe also links the moon to a specific group of Jovian satellites known as the Ananke group. This collection of moons shares similar orbital characteristics, suggesting a common origin. They are believed to be remnants of a larger object that was captured and broken apart by Jupiter's gravity long ago. The Ananke group is just one of many families of moons that orbit Jupiter. Each group provides a snapshot of the complex processes that shape the Jovian system. Hermippe, like many of Jupiter's outer moons, is quite small. Astronomers estimate its diameter to be roughly 4 kilometers, making it a mere speck compared to the gas giant it orbits. Despite its diminutive size, Hermippe reflects very little sunlight. Its surface is likely covered in dark carbon-rich materials that absorb most of the light that reaches it. This low reflectivity, known as albedo, is characteristic of many outer solar system objects, and suggests that they are composed of materials that have been exposed to radiation for billions of years. By studying the light that Hermippe does reflect, astronomers can glean clues about its composition. Spectroscopic analysis suggests that Hermippe is likely a C-type asteroid, composed primarily of carbonaceous materials. This is consistent with the composition of other members of the Ananke group, further supporting the idea of a shared origin. Section 4. A distant dance, Hermippe's orbit around Jupiter. Hermippe's orbit around Jupiter is a story of distance and inclination. It circles the gas giant at an average distance of over 21 million kilometers, placing it far beyond the orbit of Jupiter's more famous Galilean moons. Hermippe's orbit is also highly eccentric, meaning it is not perfectly circular but rather slightly elongated. This eccentricity is a telltale sign of the moon's turbulent past, likely shaped by gravitational interactions with Jupiter and other moons. Furthermore, Hermippe's orbit is tilted relative to Jupiter's equatorial plane. This inclination, along with its retrograde orbit, meaning it orbits in the opposite direction to Jupiter's rotation, further distinguishes Hermippe and the Ananke group from Jupiter's inner moons. Section 5. Windows to the past, what Hermippe tells us. While Hermippe may seem like an insignificant dot in the vast cosmic tapestry, its discovery and study hold immense value for astronomers. Small, irregular moons like Hermippe serve as time capsules, preserving clues about the early solar system and the processes that shaped it. By studying their orbits, composition, and physical characteristics, we can piece together the history of our cosmic neighborhood. Hermippe's membership in the Ananke group provides compelling evidence for ancient collisions and gravitational captures that sculpted the Jovian system. These events, which likely occurred billions of years ago, have left an indelible mark on the distribution and properties of Jupiter's outer moons. As we continue to explore the outer solar system, we can expect to find even more of these tiny witnesses to the solar system's formation. Each new discovery brings us closer to understanding our place in the cosmos and unraveling the mysteries of our cosmic origins.